Okay, these are the nth root notes. I want you to write out all the perfect squares in order from least to greatest, starting at 1, just going to 10. So 1, 4, 9, 16. So 1 squared is 1, 2 squared is 4, so on and so forth. Same with the perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, and so forth. And also do it with the fourth. So 1 to the 4th power is 1, 2 to the 4th is 16, 3 to the 4th is 81. And continue to keep practicing these on a separate piece of paper as well. You'll want to memorize these. It'll speed up your process and help you throughout the processes of radicals. Okay, so the nth root of a real number, a, can be written as a radical expression. So let's go over these terms. So an nth root, that number is called your index. Okay, this sign that this arrow is pointing to, that's your radical sign. This makes a number a radical. And the number inside we're going to call the radicand. Okay, if there is no index, like there's times where you don't see a number here, we can assume that that number is 2 and equals 2. So for example, down here, the square root of 16, we can assume that that index is a 2, and the square root of 16 is 4. The square root of 121 is 11. The square root of 189 is 17. Now, when you get to these problems, square root of 4 over square root of 25, it's all inside the radical sign. You can rewrite these as two separate radicals over each other. So the square root of 4 over the square root of 25 is 2 over 5. So now our index is 3. So this is saying we are taking cubed root. Now we need to identify that we need groups of 3 within the radical sign. So the cubed root of 8 would be 2. And the cubed root of 343 is 7. Now we have a negative within the radical. So we're going to not assume, but we can assume that that is going to be a negative within the radical sign. Cubed root of 125 is 5. If I write this out though, negative 5 times negative 5 times negative 5, all negative 5s multiplied together, I would get negative 125. So the cubed root of negative 125 is a negative 5. So if I have an odd index and a negative radicand, my answer will come out as a negative. So the same thing will happen here. Negative 1 over 3. Now we have groups of 4. Our index is 4. So this means that square root of 1 times square root of 1 times square root of 1 times square root of 1, groups of 4, my answer would be 1. Next one, 2,401. My answer is going to be 7. 7 times itself 4 times is 2,401. Next one is 8. And then you have 3 over 2. Now, so let's go over the indexes. If I have an even index and my radicand is positive and I'm using a real number, I do have two possible answers, a positive or a negative, but for now we are going to stick with positives unless we are solving for x, like an x squared equals 9 and I'm taking the square root of both sides. If my index is odd, so like cubed root, and the number inside is positive, and the number inside is real, I will have one answer and it will be positive. If my index is odd and my radicand is negative, kind of like the one we did earlier, right here, this example, and my number is a real number, I will get one answer. My answer will be negative. Now, if I have an even index and a negative number inside, we are going to get an imaginary number, which you will learn about on a later date, and you will also get two possible answers, a positive or a negative. Okay, if a radicand has more than one root, the radical sign indicates only the principal or positive root. So that's what we're looking for. Like I said earlier, we're just going to be looking for that positive square root. The square root of 117. So there's several ways to go about finding the square root. You can break it down into a factor tree, or you can figure out what perfect square goes into that number. So for the square root of 17, I know that 9 times 13 is 117. So the square root of 9 times the square root of 13, I know what the square root of 9 is. That's 3. I will get 3 root 13. Now, number 2, figure out what perfect square goes into 320. Now you can use a factor tree and break it down, or 64 times 5. So I have 4 times the square root of 64 times the square root of 5. The square root of 64 is 8, so I'll get 4 times 8 times square root 5. Simplify it even further to 4 times 8 being 32, square root 5. Okay, so number 3, as you can see, so a perfect square that goes into 48. I don't believe we have a perfect square, so I'm going to have to use 8 itself. Well, we're doing cubed roots. There is a perfect cube root that goes into 48, and that's 8. So cubed root of 8 times cubed root of 6. 6 times 8 is 48. We're looking for groups of 3, so 2 times 2 times 2 is 8. I know the cubed root of 8 is 2, so 2 times 2 times the square root of 6. We can simplify this even further to being 4 cubed root 6, not square root, cubed root. Same with 108 here, so I'll do an example of a factor tree if you've never seen one, or you have seen one, because I've done one. We can simplify this by breaking it down. Let's divide it by, let's go ahead and divide it by 4. If I divide this by 4, I will get 27. I can factor that even further to a 2, 3, 9, 3, and 3. So here I have a group of 3. This is a perfect cube, and I'm left with 2 times 2 in the middle, which is 4. So I will get 3 times square root 27 times square root of, not square root, cubed root. Cubed root of 27 is 3, so 3 times 3. Cubed root of 4, 9, cubed root 4. Okay. Moving on to the next page, I want you to try 5 and 6. So I'm expecting those to be complete, but I'm going to do this one here. So now I need 4 numbers times itself to multiply to this number, 192 or 162. Which a number that goes into this that is a perfect fourth is 81 times 2. So 3 times the fourth root of 81 is going to be 3. Fourth root of 81 is 3. Fourth root of 2. 9. Fourth root of 2. Now go ahead and watch the next video and I will complete the next part.